Did you know that an electron can be in two places at the same time? This is just one of the mind-boggling facts about quantum mechanics. Now, you might be wondering how that's even possible. Well, let's dive into the strange world of quantum mechanics with a classic experiment known as the double-slit experiment. Imagine shooting tiny particles, like electrons, through two slits onto a screen. In the world we're familiar with, you'd expect to see two lines on the screen, right? Wrong! What we actually see is a series of light and dark bands, just like waves interfering with each other. This tells us that electrons, which we usually think of as particles, can also behave like waves. So an electron can pass through both slits at the same time. Quantum mechanics challenges our understanding of the world. In the quantum realm, things aren't as straightforward as they seem in our everyday life. Now, you might ask, what exactly is this quantum world we're talking about? Great question! To understand quantum mechanics, we first need to dive into its building blocks. The smallest units in this world are called quantum bits, or qubits for short. Unlike the bits in classical computing, which can be either 0 or 1, qubits can take on both states at the same time. This is thanks to a quantum property known as superposition. Think of it as being in two places at once. Imagine if you could be both at home and at the grocery store at the same moment. Sounds impossible, right? Well, not for qubits. They revel in the seemingly impossible. Now let's move on to another fascinating aspect of quantum mechanics: entanglement. This is a phenomenon where two qubits become intertwined in such a way that the state of one qubit is directly related to the state of another, no matter the distance between them. It's like two best friends who can sense each other's emotions, even when they're miles apart. Albert Einstein famously referred to this as spooky action at a distance. Superposition and entanglement, these two principles, make qubits vastly more powerful than classical bits. They allow quantum computers to process a massive number of possibilities all at once and solve complex problems that would take classical computers billions of years in just seconds. However, handling qubits is no walk in the park. They are extremely delicate and can be easily disturbed by their environment. This leads to quantum decoherence, which is a major obstacle in building practical quantum computers. So, why are we so interested in these quirky qubits? Well, it's because they hold the key to a future where quantum computers could revolutionize everything from drug discovery to climate modeling. These quantum bits, or qubits, are the very foundation of quantum mechanics. But wait, there's more. Quantum mechanics isn't just about strange particles, it's also about probabilities. Now, let's delve into something quite peculiar: Heisenberg's uncertainty principle. This principle, formulated by the physicist Werner Heisenberg, states that we can never simultaneously know the exact position and momentum of a particle. The more precisely we know one of these values, the less precisely we know the other. In other words, it's a bit like trying to catch a slippery eel. The harder you try to pin it down, the more it seems to wriggle away. This might seem strange, but it's just how the quantum world operates. It's a world of probabilities. Instead of definite outcomes, we have a range of possible outcomes, and we can only calculate the probability of each. So, when we're looking at a tiny quantum particle, we're not seeing a fixed reality, but a cloud of possibilities. To illustrate this, let's consider the famous thought experiment of Schrödinger's cat. Imagine a cat in a box with a poison vial that will be released if a single quantum particle decays. According to quantum mechanics, before we look, the particle is in a superposition of states. It's both decayed and not decayed at the same time. So the cat too is in a superposition. It's both dead and alive, until we open the box and observe collapsing the superposition into one reality. It's a mind-bending concept, isn't it? But it reflects the heart of quantum mechanics. A world where particles can be in two places at once, where effects can precede causes, and where we have to abandon our everyday notions of reality. So the next time you see a cat, remember, in the quantum world, it could be both alive and dead at the same time. Quantum mechanics may sound bizarre, but did you know it's already part of our everyday lives? Let's delve into the practical applications of this mysterious science in our day-to-day existence. Imagine waking up to the sound of your alarm clock. The timekeeping accuracy of that device is largely due to the principles of quantum mechanics, specifically quantum tunneling. In fact, the very core of your digital alarm clock, the quartz crystal, vibrates at a precise frequency thanks to this quantum phenomenon. As you go about your day, you might use a credit card for a purchase. The tiny magnetic strip on the back of your card? That's a direct application of quantum mechanics too. It's the quantum property of spin that allows for the storage and retrieval of your card's information. What else? Well, let's consider medical technology. When a doctor uses an MRI scanner to look inside your body, they're using a machine that relies on quantum mechanics. MRI scanners work because of the principles of nuclear magnetic resonance, which is a quantum mechanical effect. It's the quantum spin of the protons in your body's water molecules that make these detailed images possible. And then there's the world of computing. Every time you use a computer, you're tapping into the power of quantum mechanics. The transistors in your device, those tiny switches that control the flow of electrical current, they wouldn't exist without understanding the quantum effect of electrons in a semiconductor. Even the lasers we use in a multitude of ways, from scanning barcodes at the grocery store to corrective eye surgery, owe their existence to quantum mechanics. They operate on the principle of stimulated emission, a purely quantum mechanical process. So, while quantum mechanics might seem like a strange, distant science relegated to the realms of theoretical physicists, it's actually working behind the scenes in your life every single day. It's in the devices we use, the medical treatments we rely on, even in the simple act of telling time. So, while it may seem strange, quantum mechanics is incredibly relevant to our lives. So, what does the future hold for quantum mechanics? Well, let's dive into the realm of possibilities. The potential applications of quantum mechanics are vast and incredibly exciting. We're about to embark on a thrilling journey into the future, where quantum mechanics might redefine our understanding of the world. Let's begin with quantum computing. Traditional computers use bits to process information, which are either in a state of 0 or 1. But quantum computers use quantum bits or qubits. These qubits can exist in multiple states simultaneously. Just imagine the computational power that could harness. It could potentially solve complex problems that are currently beyond our reach, revolutionizing fields such as data analysis, cryptography, and even artificial intelligence. Next up, quantum teleportation. Sounds like science fiction, right? But it's not as far-fetched as you might think. Quantum teleportation involves transferring the state of a quantum particle to another, irrespective of the distance between them. While we're not quite ready to teleport humans yet, this could revolutionize how we transmit information, making it faster and more secure than ever before. And speaking of security, that brings us to quantum cryptography. In a world where data breaches are increasingly common, quantum cryptography could provide an unbreakable code. It uses the principles of quantum mechanics to encrypt data, making it virtually impossible to intercept without detection. But remember, these are just potential applications. The quantum world is still full of mysteries waiting to be unraveled. The more we learn, the more we realize how much we don't know. And that's what makes it so fascinating. Each discovery opens up new questions, new possibilities, and new potential applications. So that's it, the quantum future. A world where computers are exponentially more powerful, where information can be teleported across vast distances, and where our data is more secure than ever before. The future of quantum mechanics holds endless possibilities, and we're just at the beginning. Now let's wrap up our journey into the quantum world. We've delved into the peculiarities of quantum particles, their seemingly impossible behavior that defies our everyday logic. We've grappled with concepts like superposition, where a particle can exist in multiple states at once, and entanglement, that strange phenomenon where particles, no matter how distant, are mysteriously connected. We've also touched upon the inherent uncertainty of quantum mechanics, a world ruled not by definitive outcomes but by probabilities. We've seen how this incredible science has already begun to shape our lives, from quantum computing to cryptography and even biology. And we've peered into the future, where the quantum realm promises to revolutionize fields like medicine, communication, and energy. So, the next time someone asks you about quantum mechanics, you'll have plenty to talk about. And remember, the quantum world is as strange as it is fascinating. Keep exploring, and who knows what we'll discover next.